Welcome grade 11s. My name is Hayley and I'm going to be taking you through today's session. Today we're going to be dealing with data representation, and it is the second part of our series. Now, last session we discussed data and how we get data collected and how we display it. Today we're going to be dealing with analyzing the data. So let's first go through what our key concepts are for today. In this session we'll focus on summarizing what you need to know about the introduction to the analysis of data, measures of central tendency, and the measures of spread. Right, let's go through and see what we've got. First of all, in our introduction, once we have our data and we've sorted it and displayed it, like we did last session, it is important to analyze the data. In other words, we're going to use figures to determine exactly what is happening and draw accurate conclusions from this data. This is also a way of comparing two sets of data where we look at the difference between two sets. The way we analyze this, first way, is using the measures of central tendency. The measures of central tendency are values that tell us what is happening in the middle of the data. If we know the central or the middle value, then it's possible to compare the other values in a set to that middle value. It is also possible to use the central or middle value to compare different sets of data. So once I've got that central middle value, I can compare two sets of data, or I can tell you what is happening with the data that I have collected. These are really important concepts. There are three different ways of measuring this central tendency. The first one is the mean. Now, the mean is what we in everyday language would call the average. But be careful of that word average, because your examiners tend to use average to depict both the mean, the median, and the mode. So in everyday language, we talk about the mean being average, but in our maths context, we're going to be dealing with the mean. So this is in fact what the notes say. So most people talk about the average, and it is in fact the mean. The mean is calculated by adding all the values in the data set together and then dividing by the number of values of that set. So let's look at an example, the best way to do things. I'm going to just extend the page a little bit. Right, calculate the mean of these numbers. I've got 4, 7, 15, 8, 9, 7, and 13. Calculate the mean, I'm going to add them all up and then divide by how many are there. So first, let's get our calculator out and add these all up. So I'm going to, right, it's 4 plus 7 plus 15 plus, I'm just going to go check what those numbers were, 8, 9, 7, and 13, plus 8, plus 9, plus 7, plus 13. Now I've got all of them added up, and I'm going to get an answer, 63. Now when you're dealing with a lot of numbers, I recommend that you do this more than once. I recommend that you answer the question, calculate the total, and then actually redo the total, just in case we've made a mistake entering the numbers. Then if you get the same answer, you know you're correct. And if you get a different answer, well, then you'll do it a third time and see which one was more correct. What I want to see, what I want to see on your paper is I want you to show me that number. Don't just give me an answer, and I'll explain why in a moment. So the total that we added up was 63. Now, how many of these are there? We've got 2, 4, 6, 7. We're going to divide by 7 and get an answer of, okay, take our answer, divide by 7 equals 9. I don't think I needed a calculator for that. So my answer to that is 9. Now, this is the important part. If you give me an answer only, and the answer is correct, you will be allocated 3 marks. But my mark allocation is actually for adding the, let's take those 3 away. It's actually for adding the set, for dividing by the correct number, and then for my answer. And it's normally 3 marks. That doesn't look like a 3. It's normally 3 marks. If you give me a correct answer and you say it's 9, then I'm normally going to give you 3 marks. But if you make a mistake and you added them up incorrectly, and say you got an answer of 64, but you didn't show the working, that's 64 divided by 7, and you gave me an answer which was more than 9. Let me just get that correct answer quickly. 64 divided by 7 is 9.14. So if you gave me an answer of 9.14, I would have marked it wrong if you only gave me the answer. If you showed the working, well, you would basically be getting that wrong. Let's use a different color pen so it's actually easier to see what I'm talking about. You would get the 64 wrong, you would get a mark for dividing by the correct number, and you would get a continuous accuracy mark for actually doing the calculation correctly. So the most important thing is always show your calculations, show your working out. Explain to the examiner exactly what you are doing. Okay, let's go back up to this question. We calculated the mean and we said, right, the mean was 9. Let's move on and see what else we've got. Right, calculating the median is the second central tendency that we have. The median is the value that is literally lies in the middle of all the values. It is the middle number. You have to, and this is the most important thing, you have to first order the data either from lowest to highest or highest to lowest. It doesn't make a difference unless they tell you one way or the other, but it needs to be placed in order before you're able to calculate. What happened to my pen? Before you're able to calculate the median. So let's look at our example. Same set of data. We now want to know what is the median. So my first step is actually placing them in order. Now, there are a number of different ways of doing this. We can do it by inspection, which is what I'm going to do now. You might want to take a scrap piece of paper and write all the numbers out. You might be able to use different tools, which I'll try to explain to you in a moment, to help you. But whichever way you use, you need to get them into order. So I'm going to do this by inspection. There are only 7 numbers and it's not too complicated. So my lowest number is 4, and I'm going to write these out. And then I'm going to cross it out just to make sure that I have got all the numbers. So 4, going through the numbers now, I've got a 7. There's a 7. The next lowest number is a 7. Don't forget to write the numbers twice if they appear twice. One of the quick little things that people often tend to do is, well, we've written a 7 down, so now I can ignore the other 7. No, you can't. That is really important. There were 7 pieces of information, and I need 7 pieces of information in my answer. So my 7 is duplicated, and then I've got an 8, and then 9. Right, my next number is 13, and then I have 15. Quick hint. Check to see that you have the correct number of values. So in my question, I had 7 numbers, and in my solution, I should now have 7. Have I got 2, 4, 6, 7? I've got 7, which means that I know I've got all my values. So always double check. Right, now the median is my middle number. So how am I going to calculate my middle number? Well, quite clearly, I can start counting from either side until I find the number in the middle. So if I cover each number as I go along, I will see that my middle number is actually the 8. So my median is 8. Another way you can do it is start counting from the left and then count from the right and make sure that you've got the same number. So if I count from the left, I've got my 1, 2, 3. It's my 4th number. And from the right, it's 1, 2, 3, 4th number. It's easy when you have a particular number. Then it's just the answer is 8. Let's see what happens when we've got an even set of values. So let's find the data for this set of information. Now, I've got 2, 4, 6, 8 pieces of information, and I'll go through them carefully, and you can see that they are already in order. So clearly, all I need to do is find the number that is in the middle. Start by covering. So we cover the 14 and 5, etc., etc. And now what ends up happening is I've got 2 numbers left over. Okay, I've got an 8 and a 10. But what I need is the number in the middle, which basically means that my median is actually between these 2. It's not as clear as a number like we had in the last example where we just had it as an 8. Now we have a number that is in between. So how do we calculate exactly what that number is? Well, the easiest way is to add these up and divide by 2. So what I'm going to do is I'm going to say, well, it's 8 plus 10 and divide it by 2. I'm going to show you how to do this on your calculator, and then I'm going to give you the mistake that you tend to make. So I'm going to use the fraction button. If you use your fraction button, you will not make the mistake that I'm going to explain in a moment. So I take my 8 plus 10 and divide it by 2, and I get an answer of 9. So my median in this case, my median is 9. I need to make sure a number actually lies between the 2. Now let me show you the mistake that you tend to make. Well, not necessarily you, but learners tend to make it. We say we need to add them, which is what I've done, and then divide by 2, and I get an answer of 13. Now bells should be ringing in your head, because 13 does not fall between 8 and 10. So somehow, by doing the correct maths, we've actually got the incorrect answer. And what have we actually done? What we've done on our calculator is our calculator uses BODMAS. So our calculator divides before it adds. Now in this case, we need the calculator to add first and then divide by 2. So that's the mathematical mistake we've made. And the way to avoid it is either to use your fraction button, like I did before, or you can go back to this and actually put brackets around the addition, because then the calculator will add first and then divide, and we get an answer of 9. So what I want to point out to you is 2 things. One, you must make sure that the value is between the 2. So always check. You're not always going to get 2 easy numbers like 8 and 9, where 8 and 10, where you know 9 is in between. You might get 37.2 and 37.7. And it's not that easy to quickly work out what that median is. But as long as the answer that you get, that solution, actually falls between the 2 numbers, because my median is in fact over there. Okay, let's move on to our next central tendency. And this central tendency is the mode. The mode is the average that indicates the value that has occurred the most in the given set. There are times when there's no mode, and if there is no mode, then that is an answer. If they say calculate the mode and you don't see a number that appears more than once, then no mode is the answer. There are also times when there are more than one mode, where there might be 2 or 3 modes. Then you just give every single one of those answers. So it is the number that occurs the most in the data set. So let's extend this page a little bit. In this example, if we calculate the mode, now if you remember when I added them together, I was talking about the 7 that occur twice. So quite clearly, I can see that I get 2 7s, and that is the only number that is duplicated. So my mode is in fact 7. Right, so now that we've calculated the mode, I just want to go through and compare the three values. Now with that data that we had a median and a mean of 9, and we had a mode of 7. Now what is the difference between these three values? Well, the mode is the one that occurs the most, so sometimes that is an important statistic to know. But we generally tend to talk about and compare sets of values by looking at their median or their mean. If you have data where there are huge outliers, that means huge numbers that are different to the original set, you're going to normally be looking at the mean, you're going to be normally looking at the median rather than the mean. Let's just do a quick example of comparing the two values. Now let's say, for example, I own a company and I employ 4 people and myself. So I have a secretary who gets 2,000 rand. I have a PA who gets 3,500 rand, a driver who maybe earns 5,000 rand per month, and let's go for these values. I've got a bookkeeper who I pay 7,000 rand, and it's my company, so I'm going to make the huge amount of money, and I'm going to take 75,000 rand. Does it seem fair? Not really. But let's now look at the mean and the median so we can see the difference. So I'm going to take these values and I'm going to add them up. So let's first do the mean, and we're going to add these up. So my numbers were, 2,000 rand plus 3,500 plus 5,000 plus 7,000 plus 75,000 rand. And I get an answer, of 92,500. Now, how many have I got? Now, I'm going to show you this value, so I'm going to actually go back and show you. That was 92,500, and there were 5 values. So I'm going to divide that by 5. Let's do that on the calculator. And I get an answer of 18,500. Just a pen. 18,500. Now, quite honestly, I can say, well, on average, I pay my employees 18,500 rand. But does that make sense? Mathematically, I'm totally correct. But in actual fact, when I look at all of my employees, there's not one person other than myself that is earning that kind of money. So it's not really fair to say that on average they're earning 18,500. So the mean in this case, because of this outlier, because my salary was such a huge difference to the others, the mean actually gets totally skewed. And it's not fair to say that on average everybody earns 18,500. So in this case, we would rather look at the median. So my median, and these were in order, so it's easy for me to see, my median was 5,000 rand. That is a good central tendency to say, I've got as many people earning less than 5,000 rand as I have earning more than 5,000 rand. So my median is my best central tendency in this example. Now look out for this. In an exam or in an exercise that you do, whenever they ask you which is the best central tendency, very often it is the median, because very often they have these huge outliers. So it's something that you just need to keep in mind. Right, let's now move on to our measure of spread. Right, the measure of spread. So in some cases, it's not enough to know the average of the data. For this reason, we make use of the measures of spread. These values reflect the spread of the data. Basically, how far apart are all these values from each other? This makes it very important when we're comparing two sets of data. There are two main measures of spread that we're going to use. The first one is the range. The range takes into account the highest value and the lowest value in the data set. So, in order to calculate the range, we subtract these two values. So, calculating the range of this data, again it's our data, your easiest thing is basically put it into order. You can do this by inspection, but I suggest you actually put them in order because invariably you will be needing the median at a later stage, or you might have already calculated the median like we have. So let's just go back and put these into order, and our order was, right, it was 4, 7, 7, 8, 9, 13 and 15. And I've just checked that I've got 7 of them. Right, so my range is my highest minus my lowest. Again, guys, I want to see your calculations. Don't just give me an answer. Everything that you do, show your working. So my highest in this case is 15 minus my lowest, which is 4. I hope you don't need a calculator for this, but use your calculators. You've got them. Let's use them and check everything that you're doing. So 15 minus 4 in this case is 11. That is my range, which basically means from my highest to my lowest, I've got a value of 11 in between. The next spread that we're going to look at are called your quartiles. The quartiles divide your set of data into quarters, or 25% of the data. Again, this you must first order the data before being able to accurately determine the quartiles. The median is actually your second quartile. The first quartile is the median of the lower half, and let's underline that. The median is the second quartile, or Q2. The first quartile, Q1, is the median of the lower half of the set, and the third quartile, or Q3, is the median of the upper half of the set. Before I go on to actually look at data, I'm going to just find a blank piece of paper, and I'm going to just assume those were numbers. Right, so if I'm looking at this as my numbers, what have I got? My middle number, roughly the middle, my middle number is my median, or Q2. Then I've got my lower half, and of this I find my middle number, which is Q1, and on the upper half I find my middle number, which is Q3. So effectively what I've done by dividing these into quartiles is I've divided each one of these into 25%. So there's 25%, and there's another 25%, there's 25%, and lastly, my last 25%. So that's what we mean by quartiles. We've taken our values and we've divided them into quarters. Then quite easily I can tell you what's happening in the bottom 25%, the top 25%, and later you'll see that very importantly we tend to look at the middle 50% from Q1 to Q3. But I think I'm jumping the gun just a little bit, so we'll come back to that. Right, I'm going to just delete all that so we can actually do our example. Right, and we remember that information when we do the calculations. Right, let's go up and see what our calculations were. Right, what are the quartiles of this set of data? Same set of data. We've been lucky so far that we've been dealing with the same set. Right, so the first thing I need to do, get them into order. So my order was my 4, 7, 7, 8, 9, 13, and 15. Have I got 7? 2, 4, 6, 7. I've got 7. Right, we start off by looking for the median, which we have already calculated. So if we go through this again, just as a quick reminder, 8 was my median. So my Q2 is 8. Then I need to look for the median of the lower half. Now what is important in this is that I want you to exclude the median. So in this case, it was the number 8. I'm going to exclude the number 8. I actually cross it out, and I'm looking at the median of these 3 values. And clearly, I can see that Q1 is 7. And then again, I'm excluding the median and looking at the top 3 values, looking for the middle of those 3 values, and I can see that that is 13. So Q3 is 13. Now I've got Q1, Q2, Q3, and I can answer questions related to it, which I'm sure we will do later stage. I just want to check. Okay, I want to go back to that. Right. What happens if we have an even set of numbers? So actually, I've got an extra sheet here. If we have an even set of numbers, how do we exclude our numbers? So I'm going to just go through that same set of numbers. What did we have? 8, 9, 13, 15. I just want to add an extra number, so I'm going to add a 3. To do the same calculation again, but now I've got an even set, so I know that my median is not going to be a direct number. So starting from the outside and moving my way in, I see that my median is actually between 7 and 8. So first I do is calculate Q2, which in this case is 7 plus 8 divided by 2. And remember, on our calculators, we're going to use our fraction button. Okay, and I get 7.5. So let's write that into our values. Over here. Right. So that's equal to 7.5. Now I told you earlier, I want you, when you're calculating the lower quartile and the upper quartile, to ignore the median. But in this case, my median is not a number. It is actually in between these 2 numbers. So I exclude the 7.5. I'm still excluding that, but I'm including the 7. So now my lower quartile is the number between these 4 numbers. So I actually have a number between 4 and 7. So Q1 is actually 4 plus 7 divided by 2. You can do that on the calculator. So using my fraction again, 4 plus 7 divided by 2, and I get an answer of 5.5. Is it in between the 2? It is, so I know that I've probably got that correct. So my Q1, let me get back to here, where am I? Is actually 5.5. And I do the same thing when calculating my Q3. I exclude that number, but again, it is not the 8, so I can include the 8. And now I'm looking at the number from there and cancel it, so it's between 9 and 13. And we do, again, on the calculator, 9 plus 13 divided by 2. Let's extend this page a little bit. Get a calculator out. So 9 plus 13 divided by 2, and I get an answer of 11. Is that between the 2? It is, so therefore I've got my Q3. Pen there. So that's what happens when you have an even set of numbers. Now sometimes you will find that Q1 is an exact number, Q3 is an exact number, but your median is between 2 numbers. In this case that I gave you, you had to calculate for each one. Importantly, you must show calculations and you must show working. This is one place where you probably can look for the mark allocation, although it's not always that clear. Because if it is between 2 numbers like that, we normally allocate 3 marks. Not always, normally. Whereas if it is just one number like we did before, where we got the number 8, it's normally just 1 mark. But having said that, I want you to be careful when looking at mark allocation, because sometimes if the data is not in order, then we allocate 1 or 2 marks for actually placing the data into order. So your mark allocation can be a good indication, but just be careful. Right, now what I want to do is actually just compare the difference between our range and our quartiles. Let's spell that. Right, my quartiles gave me my data into 25%. And remember earlier when I was showing you that picture, and let me take it back to that picture, where I had 25% and 25%, 25% and 25%, okay, so I had data up to there. I told you that we're going to look at the 50% that is closest to the middle. That is called my interquartile range, or RQR. And my interquartile range is actually a spread of from 25% to 75%, or your middle 50%. And the calculation for that is actually my Q3 minus my Q1. That is my interquartile range. Now, while we would use that, let's first go back to our range. In our range that we had earlier with our data, we had a range of, I'm just going to remind you quickly, we had 15 minus 4, which was a range of 11. Am I correct? We go back a few slides, you will see that. Let's just look at what our quartiles were. We had Q1, Q2, and Q3. Q1 was 7, Q2 was 9, and Q3 was 13, if you remember correctly from a few slides ago. So my interquartile range in this case is 13 minus 7, or Q3 minus Q1. And the difference between that is now 6. 50% of my data actually occurred within 6 units of each other. My entire data occurred within 11 units of each other. So what is the difference between the two? Range is a good show of spread, but it doesn't exclude my outliers. Now, if you look at that data, if you remember the data correctly, we had 4 and we had a 15. Now, 15 could have been considered an outlier and totally out of the rest of the context. So in this case, 6 is a much better spread of your central's tendency. It excludes all those very small numbers and very big numbers. So that's usually when you would use your interquartile range. Right, let's now move on to our example questions and actually put what we've learned into practice. So question 1 says, the graph below shows the car sales of 3 makes of cars for quarters over the last year. Before I go and answer the questions, I'm going to look at the graph very carefully and analyze what the graph is actually telling me. So, I have the sales on the y-axis, which is the number of cars. So going from 0 to 100, I've got them divided into quarters. I've got first quarter, see some colors, right. I've got the first quarter, second quarter, third quarter, and fourth quarter. And I've got 3 different makes of cars. So this is a typical pictogram because I've got pictures of the cars, but it is also a form of multiple bar graph. If you remember correctly from last time, we've got spaces in between, but we are looking at comparing 3 different types of cars for a particular time. Now, a quarter, just in case you don't know, is taking our year and dividing it into 4 quarters, which means that each quarter represents 3 months of the year. So my first quarter will be January, February, March, etc., etc. Now, it tells me my make A, make B, and make C, and I can see the difference of each one within a quarter, and I can compare them with each other. So I can compare first quarter. I can quite easily see that make A sold the most of compared to B and C, but I can also see that make A had a higher sales in the first quarter than it did in the second, then the third it went up to the same as the first, and finally in the fourth quarter it was the highest. So that's a nice thing about a graph like this. Right, let's go see what the questions ask us. So first question, how many units of make A were sold in the second quarter? So we're looking for make A and we're looking for the second quarter. So we're going to go to our graph, we're going to look at the second quarter. We're looking for make A. Make A is depicted with that funny looking graph. and we're going to be looking for that number. So we can quite easily see that it is between 20 and 30. It is not an exact number, and so we're going to kind of guesstimate to what it is. Now, to me, this looks like it is in the middle of that, the middle between 20 and 30. So I'm going to say that it is 25 cars. Now, don't forget to add your unit. It's not 25 Smarties, it's 25 cars. So we need to add that it's 25 cars. And there is a fair amount of leeway with this. I would probably accept any answer between 22, I would say between, say, 24 and 26, I would accept an answer. So you've probably got a leeway of 1 on either side. I will not accept 30, I will not accept 20, because quite clearly that's where they cross the line. So always look for things like that. If it crosses the line, it's an exact number, and if it's in between two lines, then it's a estimate, but 25 cars is probably your most correct answer. But like I say, there will be a little bit of leeway. Right, the next part of the question says, which make of car had the lowest number of sales in the third quarter? So now we're looking for the lowest and we're looking for the third quarter. So let's delete our second quarter. We're looking for the third quarter and we're looking for the lowest, and we can see that A was the highest, then B, and C was the lowest. So we've got just kind of like two wheels on the last car. So in this case, I'm going to say it is make C, that is the lowest. These kind of questions are really nice. They will come up in your paper 1 type questions where it's just interpreting and reading off a graph, but it is nice mark allocation. So don't worry in this case that we're getting 2 marks for just saying one thing, because the mark allocation is for reading correctly. We've actually done 2 things. So that's why there's 2 marks. We have looked at the lowest number of sales and we have looked at the third quarter. So that is why there were 2 marks. But often there seem to be 2 marks, or there seem to be a mark allocation that doesn't make sense to you. Don't stress. Let's go on to the next part of the question. It now says, compare the sales in the first and the last quarters and suggest a reason for this trend. When it says compare, we need to give them values and figures. So we're comparing the first and the last quarter. So let's go back up here and look at what do we see. So all 3 makes of cars increased drastically from the first to the third quarter. So that is one trend that I've noticed. We also noticed that in the first quarter, A was the highest, and in the fourth quarter, C is the highest. So everything that you notice about the graph, I want you to add that to your answer. Give them more information rather than less information. So let's write down that answer. So firstly, we're looking at the actual sales. So sales, we can say, are higher in the last quarter. You can add values. You can say that in the first quarter, well, we had 30 of make A, and now we're going up to 65 of make A, but it's not always necessary to add the values. So in this case, I'm going to leave the values out, and I'm going to say, well, my sales in the fourth quarter were higher than my first quarter, and then I'm going to go on to say, well, in the first quarter, make, and which one was it? I'll go back and remember. Make A was the highest. And in the last quarter, make C was the highest. Right, so that explains my compare the sales in the first and the last quarter. I've answered that part of the question. But now they ask me to suggest a reason for this trend. Now, it's only 2 mark allocation. So your reason is probably not, you need to give a reason, but you don't need to go into a lot of detail. I don't want you to waste time and spend hours writing a 3-page essay if it's only 2 marks. So What kind of reason? And I promise you, your teachers or your markers on their memo, it actually says any valid reason. Because that's what I would say, any valid reason. But let's think of some valid reasons that there could be. Right. Why do you think the sales go up in the fourth quarter? Now, dividing this into months, well, this is the end of the year. You've got October, November, and December. January, February, March. Possibly car sales are lower in the first 3 months of the year because people are still worrying about the December payments that they've made, the Christmas presents that they've spent, the extra money that they've spent going away in December. So they don't have enough money to actually spend on cars at the beginning of the year. Then they can save for the entire year and possibly buy cars towards the end of the year. Another reason could be, well, if they get a December bonus. Maybe they're using their bonus that they receive from work to purchase a car or to put down the deposit for a car. And then when we're dealing with cars, a nice thing to note is that your cars tend to change, the price of the cars tend to change year by year. So you get a new model. You would have a 2011 model this year, and as soon as January arrives, we're now going to have a 2012 model. So your payment, your actual value of the car goes down as there is a later model. Now, with cars and dealerships, if you buy a car in December, very often they will allow you to start paying in December and only give you the car in January, so you will end up with a brand new model car. So those are all little facts that you can keep into account and work out. And I don't know if it's necessary for me to write this all down, but I want one valid reason. And I promise you now, like I said, my memo says any valid reason. You've probably got 10 reasons that you can think of that will explain this information, and I haven't thought of, but it is a valid reason. I've looked at the reason and the trend for the sales being higher in the last quarter. Let's just try and find a reason for this second part where we said in the first quarter make A was highest, whereas then it was make C. And a reason I could give, well, maybe make C actually became cheaper. But any valid reason that you can think of, and you give us the reason, and you will probably be allocated the marks. Right, let's see what the next part of the question is. Right, the table below shows the number of vehicles passing two intersections over a 10-hour period from morning till afternoon. So I'm going to go through the table again before I go on and answer any of the questions. So my intersection A, and I've got intersection B. My times from 7 to 8, 8 to 9, etc., going through to 4 to 5 in the afternoon. And I can see that intersection B, I'm looking at the exact same times. So that is important to note when you're comparing things within a table, that we are looking at the same value, probably looking at the same day. It doesn't give us that information, but I'm assuming that we are. Right, and the number of cars that pass through, so between 7 and 8, we've got 351, then 245, etc., etc. It goes down a little bit, it goes up, down. We kind of have, and we can probably give this to, well, traffic. What happens 7 to 8 in the morning? Well, we're going to work, so I'd imagine there'd be more cars on the road, and etc., etc. And I'm pretty sure that that's the questions they're going to start asking us. Right, the same thing with intersection B. We've got a lot of cars, 7 to 8, and it goes down a little bit, goes up at about lunchtime, goes down, and then goes up again in the afternoon. So I'm assuming that this is on the way to work, and that's the kind of information we're going to be looking at. So let's now see what the questions ask us. Question says calculate the mean number of cars passing both intersections per hour. The mean number of cars, I'm going to need more space. The mean number of cars is what we talk about in everyday language as the average. But what we need to do is we need to add them all up and divide by how many. That is how we're going to calculate our mean. Now, when you're doing this kind of exercise where you've got two different sets of data, I want you to make sure that your notes are very clear and that whoever's marking your work understands what you're doing. So I'm going to start here by saying, well, okay, let's look at intersection A. Intersection A, and I'm going to add up all the values. So let's get my calculator out and add these values. So it's 351 plus 245 plus 102 plus 100, 235, 245. That's what I want you to be careful of. I check, as I'm going along, I check my calculator to see that I've entered the correct number. And quite clearly you can see now that I have omitted a plus sign. So 235, where was I up to? Right, plus 245, checking as I go along, plus 96, plus 155, plus 211, and lastly 332. Right, and I get an answer of 2,072 cars. Now remember I said to you, I want you to do that again. I want you to check it again and to make sure that you get the same number. Now I know that I have checked this before, so I know that it is correct. But you're always going to just do the calculation again. And remember I said to you, I want to see that total. So in your notes, I now want you to tell me that it was, let's move this down a little bit, 2072. 2072. That is my total. I want to see that calculation. And I'm going to divide by how many are there. So how many different slots have I got? 2, 4, 6, 8, 10 different hours. In fact, my question told me that there were 10-hour periods. But it's always good to double check. So I'm going to divide that by 10 and get an answer. Now use your calculator if you need to. So I've got my answer there already. I can just say divide by 10 and get an answer of 207.2. So 200, let's get a pen, 207.2. Now, first important thing that's come out. I end up with a 0.2 of a car. Now this doesn't make sense, and normally in Maths Lit what we actually want you to do is to round off till it makes sense. Now we would normally talk about 207 cars passing through the intersection or 208 cars, but we would not normally say 207.2 cars. This is the only time I want you to leave your answers exactly the way they are. Statistically, and this is what we're dealing with now with stats, we can discuss and we can talk about 0.2 of a car or 0.3 of a person. So only in stats, when we're comparing one set of data to another, while we're comparing, we can deal with something that doesn't really make sense to us. So we're going to leave it as 207.2 cars. Right, let's now move on to intersection B. Let's tell you what, let's use a different color. So now we've got intersection B. And we need to add up these values. So we're going to add all of those. Now, when I put my calculator up, it's going to cover those values. So I'm going to add them from my list here that I've got here. 455 plus 325 plus 92 plus 107 plus 344. Again, checking as I go along. Plus 378 plus 89 plus 289 plus 325, and the last one is 468. And I'm going to get an answer, 2,872. So now let's write that number into our notes. It was, I need a pen again, 2,872. That is my total that I've added up. I need to divide. Again, we've got divide by 10. Not sure if you need a calculator for this, but rather use your calculator. So we're going to divide by 10, and then we get an answer of 287.2. So 200, need a pen, 287.2 cars. per hour through the intersection. So, and we can add the cars here. Remember, I always want a value and a unit to your answer. So we've now got the two answers. Now, again, I can leave that point 2 exactly the same. Quite clearly, I can see that intersection B had a higher mean than intersection A. Have I answered the question correctly? It says calculate the mean number of cars passing both intersections per hour. Be careful of this word both, because I know your instinct sometimes is to actually add the two intersections. But when I'm dealing with these two different intersections, that didn't work, two different intersections, it said both here, not meaning adding them together. And I know that's a mistake that you tend to make. So whenever you've got data, make sure, in this case, we're comparing the two. We want to know which is busier, intersection A or intersection B. We can't add them together. And normally, if you think about it logically, it doesn't make sense to say one intersection compared to another and add the two and say, well, I've got double the amount of cars going through the intersection. I don't. I've got two separate intersections. So make sure that you understand that when reading a question and you don't just go both, therefore I must add them all up and divide by 20. So we have answered the question. Our mark allocation here was 6, which means I needed to show my calculations. So I'd clearly see that it was two separate calculations that needed to be done. Right, let's now see what the next part of the question is. Calculate the median, that's our middle number, of cars for intersection A. In this case, we only want intersection A. Calculate the median. The first step that we needed to do was to put them into an order. So I've got very varied numbers. I need to place these into some form of order. Now, I told you earlier that there's a lot of different ways of actually putting them into order. And right now, I'm going to show you something called the stem and leaf. Stem and leaf to put them into order. You can use a scrap piece of paper. You can look at it by inspection, and you can see, well, okay, which is the lowest? And then if you leave one out, you can go back and you can fill it in, and it'll take you a while to get there. But I'm going to use the stem and leaf. And I'm going to, for my stem and leaf, what I do is I create a solution where I've got a stem and the leaf. My leaf is normally one number, and my stem is the other number. So in this case, we're dealing with hundreds. So we're dealing with hundreds, with tens, and with units. So I'm going to put my hundreds and my tens into the one part of the stem, and my leaf into, my leaf are just going to be my units. So, no, in fact, I'm going to do it as the hundreds. I'm going to do hundreds, tens, and units are going to be in the other part of the leaf. So I've got from less than 100 to 300. So I'm going to write those into 0, 1, 2, and 3. Then I'll go through each number, and I'm going to go in order. So 351 means I've got 51 on that side of the leaf. That's my leaf. So that represents 351. And in each case, all I'm doing is leaving out the hundreds so that hopefully it'll be easier for me to place into order. Then I've got 245, so I'm going to put my 45 in the order there. The next one after that is 100. I'm going to go back up. 102. So 102. And then the one after that is 100. So I'm just placing them like that. It's going to make it easier for me to actually put them into some form of numerical order. Then 235. So I place my 35 in the leaf. Moving up, 245. $96, that's my 0, so I've got 96. Then I've got 155. $211 and 332. Now this is not in order, but I have accounted for every single one of the numbers. So why does it make it easier for me to place in order? Well, now I'm only dealing with one number in my less than 100, 3 numbers in the hundreds, and it's easier for me to see which are the lowest. So now writing these in order, I can see that I've got, let's change our color. Right, our first one I've got 96, and then after that, out of these hundreds, which is the lowest? Well, clearly I've got 100 is the lowest, then 102, and then lastly 155. I also double check as I'm going along. Well, I only had 1 in the zeros, 3 in the hundreds, so and I've got all 3, and now let's move on to my 200s. I've got 211 is my smallest, 245, sorry, there's a 235, 200, that's not how you write that, 235 is my next. Okay, then after that we've got 245 and 245 again. Remember, I said to you, you must make sure that you write every single one of the numbers. So if a number is duplicated, that just means that for 2 hours during the day, we had the same number of cars passing through that intersection. But we cannot exclude one of those numbers. So 245 is twice. Double check, I had 4 200s. Have I got 4 200s? I do. Now move on to my 300s. I have a 332 smaller. And lastly, 351. Now, no matter what method you use to actually put these into order, I want to double check that I have the correct number of values. So we were dealing with 10 values, so I must make sure I've got 10. So I've got 2, 4, 6, 8, 10. I've got 10 numbers, so I know that I have placed them into an order and I haven't left out any. So that is really important that you make sure you haven't left out any. One of the things I want to just point out to you now is, let's assume you did this by kind of like just inspection, and you looked through the numbers and you said, well, okay, my lowest was 96, cross it out, write it in, then my next number was going through this 100, then 102, and let's say you left out a number. I want you to make sure that you have accounted for every single number. So your tendency, I know, is, let's just assume, let me actually rewrite this. Okay, so say you looked at your numbers and you saw that your lowest one was 96, and then you wrote your next number in as 102. And you go back and you check and you see, well, okay, no, it's not 102, we actually have 100. And I know you tend to just kind of go like that and say, well, no, I've accounted for all of them. I want you to be careful of that, because what ends up happening is when you're counting or you're looking for the median, you tend to forget that there is a number actually in between here. Or if you've written it very small, you forget about it, it's not that easy to see. Rather cross this out and rewrite it as 96, 100, and 102. It is a good habit to get into. Make sure that you can read your handwriting and that your examiner can actually read what you were doing. So, okay, so that's just on the side, and we have now got our numbers into order. But what was the question? I've been so busy working on that, I've forgotten. So go back and reread the question. It says calculate the median number of cars for intersection A. So I'm going to now go through and count my median. Now, when dealing with it on 2 values, on 2 lines, I want you to be careful, but I'm going to do the same thing. I'm going to cover my numbers in order, and I'm going to go through like that, and I end up with 2 numbers left, so I know my median is between those 2 numbers. I also know that I've only got 10 values, so my median needs to be 5 on one side, 5 on the other, so I can count 5 numbers and draw my median line, and get into the habit of drawing this line where your median is. But that hasn't answered the question. I know that it falls between those 2 numbers. So my median is actually between the 2. So it's 211 plus 235, and we're going to divide that by 2. So now on the calculator, I'm going to do this on the calculator. Rather than doing it in my head, I'm going to use my fraction button, or I'm going to use my brackets, but remember your calculator does BODMAS, so if I just type it into the calculator, it's going to give me an incorrect answer. So I'm going to use my fractions, 211 plus 235, and divide by 2. And what is my check? It's 223. Let's just write that in first. Right, so my answer is 223. That was my answer. Does it fall between the two? That is my quick check. It does, therefore I'm probably correct. Do you remember earlier in the session I was telling you about mark allocations and noting that that is probably worth 3 marks? Let's look at our mark allocation here. We had 4 marks. So I'm going to guess that placing them in order was probably worth 1 or 2 marks, and then doing the calculation was worth 1 or 2 marks. So I know where my 4 marks have been allocated. Have I answered the question correctly? That's my median, 223 what? I want to say to you, 223 cars. So let's go up and check again. Calculate the median number of cars for intersection A. I have answered the question fully. Get into the habit of rereading the question. We tend to read a question, know exactly what we're going to do, go and quickly do all the calculations, get an answer, and move on to the next question. Don't do that. I keep telling you, go back and reread the question because it actually is to your benefit. You tend to miss little things like rounding off to the nearest whole number or having not answered the question exactly and in its entirety. Let's move on to the next part of this question. We're looking at the same table. It says, which intersection is busier between and during the first hour of the day? 1 mark, basically just reading off the table. So I'm going to look at which intersection is busier. Busier intersection will have more cars. And between and during the first hour of the day, so going through this, the first hour of the day, we're comparing 7 to 8 in both cases, 351 and 455. So which is the busier of the two? Very simple question. No, that wasn't the question. Moved on to a lot. Busier for the day, and this, in this case, it is intersection B that is busier, the first hour of the day. Right, then let's move on to the next question. We've now got this. Delete that. The next question says, state the mode of intersection B. What is the mode? The mode is the most. So, doing that. The mode is the most. The way I tend to remember mode is, I'm not sure how many of you used to watch Ugly Betty, and she worked for Mode magazine, and it was something that you always wanted to be. You wanted to be in the magazine. It was the most desirable, and that's how I remember that mode is the most. So we're looking for the mode for intersection B. That's the number that appears more than once. So I'm going to go through the numbers just randomly and just see if I can find any that are the same. I could have put them into order, which in fact would have made it easier for me to do, but let's try to do this one now with inspection. So going through my numbers less than 100, I've got 89 and 92. They aren't duplicated. Going through my 100s, I've got 107. That's the only 107. So it's the only hundreds I've got. Going through my 200s, I've got 289. So clearly that's the only one. It's not one of those. The 300s, I've got 325. Have I got another 325? I do. So I'm going to just mark those. I'm going to check the rest. 344, is there another one? No. 378, is there another one of those? No. And 400s, I've got 455. There's only one of those. And 468, there's only one of those. So in this case, and I've checked every single number that I've got. In this case, I can say the modal class was 325 cars. Remember, I told you if there is no mode, that is an answer. So let's assume one of those were 326. Then my answer would be no mode. And all you would do is actually write in here, no mode. That would be a correct answer. if there was no mode. In our case, we do have a mode, so we write it in. And if we had more than one mode, we can have more than one, and all you do is 325 cars and whatever your second number is. So you can have more than one mode. Right, moving on to the next part of the question. If the city council only has a budget to install robots at one of the intersections, which would you recommend, and give a reason for your answer? All our calculations come down to this question. So I think we need to go back and check what our calculations are. So let's go and check what the first part of the question said. Right, where was when we looked at the mean. Our mean number of cars, intersection A was 207 cars, to intersection B was 287. So I think that's a very important fact, that the mean is higher for intersection B than it is for intersection A. So we're going to remember that fact, and then we're going to go through here. Well, we needed our median. We didn't calculate the median for B. So we can't compare the two medians, but we have got a very good comparison with the mean for A. And then we looked at the first hour, intersection B was busier. And lastly, well, the mode, again, we didn't calculate the mode for A, so we're not going to look at the mode. So basically what I'm going to tell you is I'm going to look at two things. I'm going to look at the mean was higher for intersection B than A, and it was quite drastically higher. It was 287.2 compared to 207.2 cars. So we had 80 more cars going through intersection B every single hour of this 10-hour shift. And the other thing we're going to look at, well, the first hour intersection B was busier. And again, it was quite a lot busier. If you look at the numbers, we had 455 compared to 355, almost 100 cars more. So if we only had to put one robot into either one of these intersections, I think we would go with the robot at B. Robot at intersection B. And what would your answers be? Well, we've based it on this information that we've given them here, but then I would say because it is busier. Because we've calculated it's busier, because it's busier. We can also have a look at specific times of the day, like we did first thing in the morning. We see that it's busier in the first hour, it's busier in the second hour. So we could actually do something like that, and let's look through each hour. Well, it's busier first hour, it's busier in the second hour. Okay, then it's not busier, slightly busier in the fourth hour. And then lunchtime, it's much busier, much busier. Again, okay, this one's busier here. It's busier there between 2 and 3. It's busier between 3 and 4, and finally it is busier between 4 and 5. So in actual fact, if I had to look at just the data and not base it on my calculations that I've done and calculated throughout the question, I can also say, well, 8 out of the 10 hours that we were examining, intersection B was busier, and therefore I would put a robot at intersection B. Question 2 says 52 learners wrote the grade 11 geography examination. The ages in years of the sample of 16 of these learners are as follows. So what I have here is I have a sample of 16 of the 52 learners and their ages. So I'm going to look through all the ages and then go on and answer the question. So I've got 16-year-olds, I've got 1, 2, 3, 4 of them. 17-year-olds, I've got 1, 2, 3, 4, 5 17-year-olds. And then 18-year-olds, I've got 4. And finally, 3 19-year-olds. Right, now let's go through and answer the questions that related to this sample. Now, before I carry on, a sample means a portion of the whole. So rather than having all 52 ages here, we've just taken 16 kids at random and we're only looking at their ages. So a sample is a part of a whole study that you're doing. The first question says, what age sample is the mode? So I need the one that occurs the most. So I'm going to just quickly make little notes here. So 16-year-olds, well, I had 4 of them. 17, I had 2, 4, 5 of them. 18, I had 4 of those. And I had 3 19-year-olds. So which is my modal class? That's the one that occurs the most. So it is 17 years. Don't forget your unit, 17 years. Determine the median age of the sample of learners. The median is my middle number. So looking at my data, I must remember they must be in order. So are these in order? Yes, they actually are. So let's delete all these little scribblings that we've got so we can now work out the median. So my median is, I add from either side. I'm going to block them off like that and block them off like that, and I end up with 2 values which are between 17 and 17. And so I'm going to actually, well, the number between 17 and 17 is 17. But let's go through the calculations of what we did earlier. We said 17 plus 17 divided by 2. And I'm going to use the calculator just to show you, because you tend to sometimes make a mistake. So, and I'm going to use my fraction button, 17 plus 17 divided by 2, and I get an answer of 17. Is it between the 2? Well, it is the 2. So the number between 17 and 17 is clearly 17, but we're just double checking all that. So my answer is 17 is my median. I know that if you use your calculator without the fraction button, you tend to make a mistake. So I'm going to just quickly remind you of that mistake that we made. If I say 17 plus 17 divided by 2, I get an answer of 25.5. Clearly, I can see that it is incorrect. And I know this is a mistake that you're going to tend to make. So remember this mistake and don't make it. Your calculator uses BODMAS, and we need to add before we divide. So double check, it is the same. If you get an answer like this, a question like this, you don't necessarily have to do the calculation. If you can see that, well, if it's 17 on either side, then clearly the number is 17. Just give an answer, that's fine. And you can see your mark allocation in this case was only 1 mark. So an answer would have been just perfect. The next part of the question says calculate the mean age of the sample of learners. So we need to calculate the mean, we're going to add these all up. Now, when we're adding numbers that are duplicated like this, what we can do is actually use the fact that our calculator does BODMAS and say, well, okay, there was 16. Rather than saying 16 plus 16 plus 16 plus 16, which I can quite easily do, I can say there was 16 and there were 4 of them. Now, I know my calculator is going to multiply before it adds, but you can use brackets if you want. How many 17s were there? There were 17. There were 5 of those. So I'm going to do that, plus 18. There were 4 18s. And lastly, 19 times 3. Now, if you're going to do a calculation like this where you're using multiplication and addition, I just want you to be very careful and check that you actually have added when you need to add and multiplied when you needed to multiply. So let's just go back and double check my calculations. I've multiplied the first, then added, multiplied, then added, multiplied, and finally I have added and then multiplied. So my answer should be totally correct now, 278. It also makes it easier for you to not miss out a number. So when I'm adding all of these one at a time, you tend to get confused, well, how many 16s have I entered into the calculator and how many do I really need? And it's easy to make a mistake. So if you have numbers that are duplicated, rather use this method. So I've got 278 and I'm going to add that number. So write in the number. I've got 278 learners. That's my total age. Divide by how many? And I'm always going to show this calculation as showing the number. Double check, do the calculation again. So how many values did we have? Well, it told me that there were 16 in the samples. I'm just going to double check. So it was 2, 4, 6, 8, 10, 12, 14, 16 of them. So I'm going to take 278 and divide it by 16 and get an answer. Don't do that on the calculator. Divide by 16 equals to 17.375. They don't tell you otherwise, round off to 2 decimal places. So I'm going to say 17.38 is going to be my answer. So 17.38 years. If they don't tell you round to 2 decimal places, does it make sense that I've got 0.38 of a year? Well, it could, okay? Our calculations are dealing with 17-year-old or 16-year-olds so far in our sample. It doesn't tell us about months in between, but that is my proper statistically correct number. So I'm going to leave it as statistically, that is my mean. And because I'm dealing with a sample, that probably represents the entire 52 learners. Well, if it's a reliable sample, of course. Right, let's move on to the next part of the question. Before we move on to the next question, I just want to go double check. Have I actually answered the question correctly? Reread the question, as I keep telling you to do over and over again. Calculate the mean age of the sample of learners. I have done that. So now I can safely move on to the next part of the question. Right. The geography examination marks expressed as a percentage of the 52 learners were recorded as follows. Now I've got 52 pieces of information. So a lot of values, and if I look through them, they are in no particular order. So that is important for me to note, they're in no order. The first question says, determine the range of marks. So what is the range? The range is my highest value minus my lowest value. So that is my range. And it's another good habit for you to get into, is if you write out the formula of what you're doing before you actually answer the question, it makes it easier. So you know exactly what you're looking for. So right now I'm looking for my highest number and I'm looking for my lowest number. And there are 52 values. And this is quite a huge task to actually go through all these values and analyze which is the highest and which is the lowest. So you might want to put them into some form of order, but I think by inspection we will probably find it. So I'm going to go through each value and look at it and kind of like, is it high or is it low? So if I look at them briefly, I can see I've got like in the 80s, and I can see I've got kind of in the 20s. I'm going to eliminate all the other numbers. So anything that's not in the 80s, until I find a bigger or smaller number, I'm going to eliminate. So I'm going to go through the numbers. That was an 80, but I knew that was 89. So let's not eliminate it for now. I'm going to eliminate all the other numbers that's higher. So now I've got 90s, so I can eliminate my 80s. And I'm going to eliminate. There I've got a 20, so I'm going to leave that one. Eliminate my 40s. And this is a good way of checking for a high and a low. I just want to double check that 83 was actually crossed out. Doesn't seem to be. Right, 89 I can cross out now. We're looking for 90s. So eliminate. 27 is a number, but I had a 20 which is lower. So I can actually eliminate it, even though I have it is a 20. So eliminate my 40s, 50s, 60s, 70s. 22, again, was higher than 20. So I'm going to eliminate that. Right, 98. 98 is higher than 90. So I'm going to eliminate my 90. Now I've got my 98 as my highest. 89 I can eliminate. 29, 20 was lower. And I'm going to go through every single one of these numbers like this, because that way I avoid missing the highest and lowest. 95, 98 was higher. Those 89s, that was we crossed out already. Okay, and carry on eliminating all the numbers. And I suggest you do this in pencil because we're probably going to need all these numbers again. So you've got to make sure you can still read the numbers that you are needing. Right, and there's a number, 99. Well, clearly that's higher than 98. Now what am I left with? I'm left with two numbers, which are clearly my highest and my lowest. So if I now write that in, my highest number is 99, and my lowest number, go back to my tip, was 20. So 99 minus 20, and that's going to give me my range. So I'm going to do that on the calculator just in case. 99 minus 20, and I get an answer of 79. So go back to here. Right, my answer was 79%. Remember, we've always got a reference. And what were we dealing with here? We were dealing with geography expressed as a percentage. So 79% was my range. What does that mean? It means everybody that wrote this test, all 52 learners, had a mark within 79% of each other. That is a huge range, and it's probably realistic when you're dealing with 52 learners. So from your highest to your lowest was 79%. Right, let's move on to the next part of the question. The National Curriculum Statement requires that results be expressed in terms of 7 performance levels rather than percentages. Now these performance levels you've probably seen on your reports. They're the 1s, 2s, 3s, etc. So our percentages go from 80 to 100, 70 to 79, 60 to 69, 50 to 59, 40 to 49, 30 to 39, and lastly 0 to 29. And those are each signified by a number. As a result, the geography teacher needs to work out the number of learners per performance level. So we need to complete a frequency table to work out the number of learners per performance level. So what we're going to do is let's set up our frequency table. So on my frequency table, I've got my category, which in this case is my performance level. So my performance level is my first category. Then I'm going to be using a frequency table, but I'm going to first do it as a tally. And then finally, I'm going to give it a frequency. Now, I'm probably going to need more space for the tally. Tally, and then finally the frequency. Right, and we're going to do that for each one of these 52 learners. So I'm going to place my performance levels in order. I'm actually going to start with 0 to 29. Then I had 30 to 39. Then 40 to 49. Let's move down a little bit here, extend that a bit. 50 to 59. 60 to 69. 70 to 79. And lastly, 80 to 100. Just for your information, I'm going to give you the criteria on the side, the numbers. That is number 1, 2. Let's do that in a different color. So those are the criteria 1, 2, 3, 4, 5, 6, and 7. So those are your criteria numbers, and that's what you see on your report. When you get a mark, you normally get a 3, a 4, a 6, a 7, hopefully lots of 7s. Right, now we need to complete this tally table. And this is an important fact. I want you, we've got 52 pieces of information that we need to place into that tally table. What I want you to do is I want you to go in order of the numbers as they are written and rather fill them into the tally table rather than going and looking for all the numbers. Remember how long it took us to find the highest and the lowest? And we still went through every single one of the numbers. If I'm doing this by observation and I'm saying, well, okay, my lowest number was 20. How many 20s did I have? 20. And then looking again, well, there's another one. It's very easy for you to miss out a number. So rather than doing it this way by inspection, I want you to go in order. So we're going to start at 54 and then move on to 67, and as we go through, we can cross them out. So, but it's not going to fit onto my page, so I'm going to have to, let's just extend this. I'm going to have to call out the numbers to you as we go along, and we're going to fill them in. Before we do that, I just want to draw some lines so that they're not the straightest lines in the world, but at least it is a little bit neater and I know where these are filling in. Right, so I have got it a little bit neater. Right, so my first number is 54. 54, and all I'm going to do is fill a tally table in. So I'm going to tally, remember, 1, 2, 3, 4, and then 5 we cross out. Then I've got a 67, so 67 falls there, 83, 34, and we just do this for each one of the numbers. 49, where does that fall? 56, 78, 89, 90, 79, and be careful of your numbers, your whole numbers or your nines. Make sure you've put them into the correct number. So 20, make sure that you've got it in the correct category. It's very easy to place it into the wrong category. Right, I've got 49 and 50. So 50 falls into that category. Right, 70, 89, 57, and then a 27, 48, 56, and now cross, there's my fifth. See, the nice thing about doing it this way, where you go through in order, is if you do get distracted, you can go back to your notes and you know exactly where you're up to. So right, we move on to the next number, which is 70, and then we've got 22, and just double check as you're going that you're actually putting them into the right place. 98, 89, that didn't cross out too well, 29, 56. Right, in the next row, we've got 47, 95, 49, 67, 89, 48, 46, 89, 63, 75, 45, 50, 58, and finally the last row we've got 73, 67, 45, 76, nearly done, 70, 38, 46, 37, 47, 36, 38, 99, and 55. Right, once we've got our tally table, we can now get our frequency. So the frequency is just converting these tallies into number. So for 0 to 29, we've got 4, 30 to 39, we've got 5, 40 to 49, we've got 11, 50 to 59, we've got 9, 60 to 69, we've got 5, 70 to 79, we've got 8, and 80 to 100, we've got 10. So this makes it easier for us to now interpret this data that we had 52 values. We had 52 values and we knew that the range was 79%. But now we can quite easily see that 10 people got level 7 and the majority of people got between level 3 and 4. You know, we got a very high 30s. And the nice thing about this, we can see our modal class. So our mode, remember we were talking earlier about a mode, and so far I've been dealing with a number, but the mode can also be a class or an interval. So my modal class is my highest number. So my mode in this case is between 40 and 49. That is my modal class. It means most people got between 40 and 49 for this test. All right, so that takes us to the end of the question. So I just want to do a quick recap of what we've been looking at and give you maybe some hints for your homework. We've been dealing with our data analysis, comparing one set of values to another set of values like we did with our intersections, or being able to interpret and get like a modal class for our geography question that we've been doing. And this allows us to analyze the data, and it's very important for you to remember the difference between your mean and your median, your mode, your ranges, your interquartile range, your range when your highest minus your lowest. So just keep those all in mind when you are analyzing data. For your homework, what I want to see is I want to see all calculations. Don't forget to show every single step of the way what you are doing to work neatly. And when you are adding up numbers to make it the median, to calculate the mean, I want you to add them up more than once to make sure that you've got the correct number. But clearly show us all calculations so that we can even have method marks if you do tend to make a mistake. So good luck with the homework, and I hope you enjoyed today's session. Thank you.